All right, we're live. Okay, Isa, if you want to start reading.
Okay. Okay, so the first question, number 3 says, what is the value of the test statistic? So I guess there's like some spreadsheets we have to open here, huh?
Yeah, I'm downloading them right now. Well, I think we can already do the first questions without the need of what we downloaded, because I think we have already everything we need
Okay.
from the information.
So it says the test statistic.
Hmm.
So yeah, it's D bar plus or minus D bar the T score, right?
Yeah, we have to find the t-score, so because that's the test statistic. So we have to do d bar minus the mu d, that it's like 0, and divided by the SD over the square root of 9, if I remember correctly.
So yeah, because 9 is your population, right? So you always get the square root of that. And then
Yeah,
you
it's your
said
sample.
yeah, excuse me, of your sample. You said that you get the D minus the what?
The population, like
Yeah.
what we did is that we were using the population mean,
Uh-huh.
but here we don't know it.
Yeah.
So we are supposing, like, our null hypothesis
Yeah.
states that it's 0.
0. Okay.
Yeah, so we should do that. We should do d bar, the 2.2 minus 0. I'm trying now to get to the textbook
Mm.
somehow. I don't have it here. I'm going to open the textbook. Uh, 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 uh. So So you see, like, it says here, the test statistic for a test involving paired data when sigma is unknown is a t. For this situation, the value is, and then you see that they used the d bar minus 0, that is the alternate, sorry, the null hypothesis, divided by s divided by the square root of n.
That's in the textbook you said?
Yeah,
Okay.
yeah.
I have my textbook pulled up. What part did you type? So I can just like type it up here.
Well, it's chapter 12,
Yeah,
and
chapter 12.
it's down. Um, I'm checking how to explain it to you. In step 4.
Step 4. Okay.
Mm,
Confidence intervals.
No, it's verify the requirements have been met. You have to scroll down a bit. You will see like some blue boxes, and then you scroll a little bit more, and you see a histogram. Then you see a QQ plot, and it's just below the QQ plot.
Okay, I see. T minus 6.8 over minus 0. Okay. So 2.2 minus 0 over. So in this case, what would be the 3.17?
Sorry?
The 3.17 in our case would be 3.3.
Yeah, it's the S. It's the S.
Yeah, so, okay.
So we have to do, let me open my calculator. So it's 2.2 divided by 3.3 divided by the square root of 9. That's like 3. And I come up with 3. Oh, sorry, 2.
So just straight 2?
What do you come up
I
with?
got 2 also.
Yeah. Well, because we do 3.3 divided by 3, it's 1.1. And if you do 2.2 divided 1.1,
yeah,
it's 2. Okay. Question 4.
Okay, so yeah, question 4. My computer's. Okay, question 4. The probability of obtaining a test statistic greater than Jordan's test statistic is 0.0403. Use this probability to determine the p-value of the hypothesis test.
we do the T distribution of this.
The probability of obtaining a test statistic greater, it's 0.0403. So we're looking at something that it's not equal. So we should probably just double that. Because not equal, it's double-tailed. So here it's saying if it's greater, it's 0.0403. So I would say 0.08.
And we just put that in the T distribution.
I didn't. I'm just reasoning. You know, it's like.
Yeah.
But if we do, oh my gosh. Also, because if we put it in here, in the applet,
yeah, it
doesn't say that it's 0.0. It says 0.0697.
Let's see here.
So here it says 0.0403. The probability of getting a test statistic greater. Yeah, because his hypothesis test is different. It just says different than 0. So I would say it's 0.08. We can probably.
Yeah. So here's what I did. Let's see if I can show you guys. Can you see my screen right now?
Mm-hmm.
So I just put the 0.08 right here, you know? I got that.
Yeah, but that's not the t-score. You know, like what it's saying here is that the probability of obtaining a test statistic greater than 2 is 0.0403. So what I did, I put 2 in 2 equals t. But like if I only shade the area above t, it comes up 0.0697. Oh, but it's, wait, I did, but it's with 3 degrees of freedom. Here we have 8. So it's 0.04. Yeah. Yeah, it's right. I'm sharing it. Just a second. So, just a second.
So okay, just one more time. Where did the 2 come from? The 2 t?
Just a second. Do you see my screen?
Yeah, I see it. I see it.
Okay. So I put 2 in here. Now it's the data that we just got. And then you have to input here 8 degrees of freedom. So degrees of freedom, it's n minus 1.
Okay.
And if you put 8 degrees of freedom and 2, and you only shade this one, you come up with 0.0403. That is exactly the one that we have there. So we're doing not equal to, so it's this one, and it's 0.08.
Okay. Thank you.
You are welcome.
So would it be 0.081 then? Because you round it?
Oh yeah, you have to round to 3 decimals, right? Yeah. Good call.
So we'll read the next one.
Mm-hmm.
Use the data file chapter 12. Test and SPSS. Be sure that the test does group 1 minus group 2. Use a null hypothesis of H divided by B equals 0, and alternative hypothesis different than 0. And level of significance equal 0.1. What is the test statistic?
Oh. I opened up the wrong one.
A1. So one is called data B, the other one is data A, right?
Mm-hmm.
Okay.
I'm also opening the other file right now, so we have everything. All right. So, what do we have to do again? Perform a paired sample. Be sure that the test does group 1 minus group 2. Okay. So we have to find the difference. Group 2.
Well, I think I got 0.407 for my t-score. I don't know what you guys got.
Hey, can you speak louder?
Yeah, I got 0.407.
Okay.
Sorry,
0.407. No? Did you get something different?
I got 0.276.
What did you get, Daniel?
I got 0.276. Let's
Both of you guys
see.
got the same answer?
Wait. Null hypothesis is 0.
0, right?
So it's 0.407. Yeah, I forgot to input the right null hypothesis.
Okay.
Yeah.
Okay, cool. Here's my question, because like I have the quantitative inference procedures sheet right now opened.
Yeah, me too.
But I think in the video, I think it said like, oh, that's not like it, because he uses another program, and the p-value that he got was different from the one that I have. See, for example, right now I have 0.6887. Is that what you have?
No, I have
You don't.
34438, but it changes on the type of test that you do. You have to change that because I am looking
mine's
at
not equal
greater.
to.
Mine is greater than, so it means that it's half of it. So if I put not equal to, it's 0.688774357.
Yeah, that's what I got. Isn't it not equal to though?
Yeah, it is. I just didn't
Okay.
check it yet
Okay.
because it wasn't in the question, so I didn't input it yet.
Okay.
So the test statistic, how many 3 decimals? So it's 0.407, 0.407. No, question 6. You say?
So yeah, p-value
407. So the p-value it's 0.689.
And then we failed to reject it, right?
Yeah, just a second.
Spending 5 on the one.
0.689. So
What is the correct decision based on this?
I would fail to
Yeah, we
reject it.
fail.
Yeah.
That's what I think is correct.
So suppose your alternative hypothesis is instead greater than 0. What is the correct decision? So let's change it to greater than 0.344. We have
insufficient evidence, right? I'm gonna go with B for that one.
I would say so, yeah. What sayest thou?
My Excel is giving me some trouble. So
Okay, well, like if we do
what's
the greater than, the p-value, it's half of the one we had before. So it's like 0.345. And we have a level of significance that it's 0.1. So we're still out.
Still out.
So we're still failing
Still above.
to reject the null hypothesis, but we have to choose which of the 4 in question 8.
Okay. We have insufficient evidence. We have sufficient evidence. Well, we have sufficient evidence that the mean of difference is greater than 0.
Hmm?
We have sufficient evidence that
I think it's the second.
Too.
Just because we never confirm the null hypothesis. We're either rejecting it or not rejecting it. So we usually say that we do have enough evidence or not to overthrow it, but we never confirm it. So like saying that we have sufficient evidence that it's equal to 0, it's almost like confirming that that's the population mean. But we never really do that.
Well, I can understand why we fail to reject, but
Because we usually word we have sufficient evidence when we are rejecting.
yeah, okay.
But like,
So we have insufficient evidence.
we have insufficient evidence that the mean is greater than 0.
Okay, makes sense.
Well, let's try that and we'll see what happens. You know.
Yeah.
So use the data file, chapter 12 data B1 to answer the next 8 questions. Perform a paired samples t-test. Be sure that the test does group 1 minus group 2. This data comes from nosocomial infections. The null hypothesis is 0. The alternative hypothesis is different than 0. Level significance 0.01, which is greater, N or DF.
I think.
N, because DF is N minus 1. So the P, let's see. So we have to do group 1 minus group 2, right?
Yeah, that's what I did.
Cosa speciale? Solo i valori. Tac. Not equal to, right? Yeah, not equal to. So p-value, I have 0.001. What did you come up with? Is a
I got 0.00121. But yeah, so it's basically
Yeah.
it's the same thing.
so 0.001.
Still working on this.
We would. So the next question says, "What decision do you make?" Well, it's smaller than the level of significance, so we reject the null, right?
Just a second, because I was just telling him.
Not equal.
Not equal to, yeah.
So what did you get as p-value?
0.001.
0.015.
No hypothesis.
Oh,
It's 0.
yeah. 0.001.
Yeah, exactly. So what decision do you make? I would reject.
Yep, because it's smaller than
Definitely lower than 0.01.
Yes.
Okay. So you decide to try another alternative hypothesis. This time you use greater than 0, and you keep the same level of significance. Did the p-value increase or decrease? Well, I'm not looking at it, but it will decrease. It's going to be half, because before was not equal to,
Yeah.
so it was like on both
We have
ends.
just one side of the diagram.
You know, let's do it just to be sure. Greater than, in fact, it's 0.0006, so it's like smaller.
And what decision do you make? You reject.
Reject the null.
Oh, I'm
So
sorry,
for the
guys.
question
I'm
as well-
a little sick.
Are
I
we-
keep
are-
sneezing.
Are we on 12 right now?
Well, yeah, we did 12 and 13, one as the consequence of the other.
So we reject.
So we said for 12, we said that it decreased.
Yeah, for 12 it decreased, so it's like 0.999, right? Is that
No, it's like point 0.0006.
oh, that the greater than test, right?
Yeah,
Okay. So it
because like
increased then.
greater than the p-value will be
Decreased though.
the double. Sorry, the half of not equal.
Uh-huh.
Because not equal takes both ends of the curve. Greater than it just the greater than the far right. So we said decrease for 12, and we would reject the null hypothesis for 13.
Would reject the hypothesis, yes. Okay, 14. Based on your response from the previous question, what conclusion do you make?
So we have sufficient evidence.
Since we reject the null.
I would go with the third one. We have sufficient evidence that there is a difference.
Yeah. So yeah, I would go with that one too. Just because number one, it starts out the same, but then it says that there's no difference, but when in fact there is.
Yeah.
Mm-hmm.
Okay.
So question 50.
As we have.
Sorry.
Yeah, as we have seen. Oh, I'm reading.
Oh, okay. Sorry, I didn't understand that.
No, you're good.
Yeah, just go ahead.
You're good. Sorry. As we have seen, the p-value depends on the alternative hypothesis. In general, which alternative hypothesis will give the smallest p-value?
Well,
Smallest p-value. Would it be the fourth one?
It's the same. Like
I would say the second one and the fourth one.
Huh. That's weird.
I guess both, right?
No, we cannot do that. We cannot select both.
Well, they are the same. They.
Well, if we turn to the less than in this with the data that we just used, it's like 0.999. Because, well, it depends. Because if we have a positive t-score, the lower p-value will be greater than. But if we have a negative t-value, the smallest p-value will be less than.
So maybe C then, right? Is that what you're saying? Is that what you're thinking?
Not enough information. Depends on the problem. Because if you think about it, if you look just at the positive t, greater than, it's just a small bit of the curve. Less than, it's like almost all of it. But if we're looking at the negative t, the less than, it's going to be just a little bit of the curve. But if it's greater than, it will be like all of this.
It kind of makes sense, yeah.
We have to hurry up because my battery is going.
Oh, so not enough information.
I would say not enough information.
All right, let's move on.
Then we'll see.
So 16, what is the point estimate for the 95% confidence interval?
Determine the 95% confidence interval for the mean difference between the two groups. Input your answers below. So we're always using the same data, always like the B data, yeah?
I think so, yeah.
So 95% confidence interval. What is the point
What is the
estimate?
point?
Huh, I'm confused.
I don't know what that one is either. I'm just kind of moving on to the margin of error one because I don't know that one.
So this is not equal to, right? We're doing not equal to. Because that was our,
Yeah.
yeah, not equal to. What is the point estimate? What is the margin of error? I'm really confused. 16.
Okay, so.
It's the confidence interval. We replace the population standard deviation sigma with its point estimate S. The appropriate distribution is a T rather than a Z. So the point estimate is the S.
Oh, isn't point estimate just like the
Because point estimate.
standard?
Sorry, what did you say?
So I'm looking at this. I will show you kind of what I'm looking at right now. Let's see here. So right here.
Okay.
Could that be it? The center part? The point.
Well, like here in the textbook, it says that the point estimate is the sample's standard deviation.
Sample standard D. So is that just
Okay.
But let's see for a second. Point estimate. So interval, a point estimator gives one specific value as an estimate of a parameter.
does it have a formula?
I'm just checking because the statistics above are called point estimators. So because they're just one number that is used to estimate a parameter. So all the sample means, sample standard deviation, sample variance are all point estimators. So what is the point estimate for this 95% confidence interval? I really don't know what it's asking.
Yeah, I don't know either. I don't even remember doing that in the videos. Do we want to move on and we'll just kind of come back to that one right now?
Yeah, let's try.
All right. So for question 17, what I did was I just was using this formula, the t times SD over the sample size. I got 11.95. I don't know if that's right.
It doesn't sound.
Yeah. It just I'm not really trusting it either.
So we're doing not equal to, right? What is the confidence interval that you get?
So I get 5.303.
Yeah.
And then the upper bound is 18.607.
Yeah, me too. The mean is 11.955.
Yeah, that's what I got. Standard
So
deviation is 15.
if we do the mean minus the lower confidence interval, it's 6.652. So that should be the margin of error. Yeah, 6.652. Because the margin of error, you know, it's that distance between like the mean and the two bounds, lower and higher. So if lower bound, we said it was 5.303, right? Okay. And the upper bound, 18.607.
Hey guys, I got 100% right now.
Yeah? So what did you
So,
put
yeah.
in 16?
Remember that one image I showed you that was online?
Yeah.
I get like, yeah, I
Yeah.
just put 11.955 and it's correct. So
Okay.
yeah,
because probably because it didn't specify which point estimate, so we should probably just use the main 11.955. All right. Save all. No, you're not. Yeah, your computer froze.
Yeah.
So
Okay, I'm submitting it. Let's see. Where am I? Yeah, 20 over 20. That's cool. All right, so
Okay.
I think
all right, guys.
I can stop it. All right.
All right.
See you Thursday.
Hey,
See you, Thursday.
All right, bye.
Bye-bye.